Hi, good evening all. Today we are going to learn about a type of network in electrical circuits which is nothing but lattice section. So what is this lattice section? So this is nothing but a network which consists of crossing each other. That is called lattice. This is nothing but a structure crossing each other. Crossing each other. So what is this lattice means? Let's try to see here. Here we have an impedance of ZS1 series impedance. This is ZS2. This is applied voltage V1. This is one more applied voltage V2, and we have an cross arm here. So these are the cross arms. We have an impedance of ZD2. So there is no touching here. So this is called ZD1. So where ZS1, ZS2 are called series arm impedances. So this is very very important. If you learn all these things, only you can understand a given network. These are called series arm impedances, where Z1 and Z2 are called as diagonal arms, or these are called as cross arm or diagonal arm impedances. Next, we want to identify whether it is symmetrical or unsymmetrical. So this is ZS1, ZS2, where these are two different impedances. This is ZD1 and Z2. This is also unequal impedances. Therefore, symmetrical means when you fold it half, you can see here, these are not same. Therefore, I can say that these are not different. Automatically, I can call this as an unsymmetrical lattice section. So if you fold like this, for example, half of the paper if you take, and if you fold ZS1 is not equal to ZS2. Sir, how to understand this one? If you take ZS1 is 3 plus J4, ZS2 is 4 plus J5. So therefore the impedances are not same. So I can say that this is an unsymmetrical. I mean, when you draw to a line like this or horizontal or vertically you write, and you see that ZS1 is not equal to ZS2. Therefore I can say that this is an unsymmetrical lattice. Now how to convert this unsymmetrical into symmetrical? It's very simple to analyze. So try to draw this impedance. This is a series of impedance. I'm going to label it as some ZS, and one more series of impedance I'm going to label as ZS. You can see here both ZS are same, and I'm going to have the diagonal arm impedance. This is one diagonal arm impedance. This is another diagonal arm impedance. So this I'm going to call it as ZD. This is also ZD. So you can say that the series arms ZS is equal to ZS, and the shunt, I mean diagonal arms ZD is also same. I can call these kind of networks as symmetrical lattice section. This is how to write down symmetrical and unsymmetrical lattice network. So now let's try to understand about a bridged network, a bridged T section. So just understand, if you have crossing, therefore those kind of crossing sections are called lattice sections. So ZS1, Z is two different, that's what is called unsymmetrical. So already I told how to classify a symmetrical and unsymmetrical. If you are unable to understand symmetrical and unsymmetrical, you can watch my previous video. So this is very simple to understand. You take a white paper and fold it into half. The area of the half paper is equal to the area of the another half. Then I can claim these two areas are symmetrical with each other. That's how to identify symmetrical. Now let's try to see the bridged T section. Bridged T section. So generally, how to construct a bridge? We know that. So we are going to have nodes 1, 2, 3, 4. Okay. So I'm labeling this as some 1, this as some 2, this has some 3 and 4. Let's try to understand between 1 and 2. I'll apply the voltage, and I'm going to have the impedances I've shown here. This I'm going to call it as ZD diagonal, and this I'm going to call it as ZD, and this I'm going to call it as ZS, and this I'm going to call it as ZS. So generally the product, okay. So here generally we will connect an galvanometer with the remaining two terminals. 1 and 3 we apply the voltage. Galvanometer will be connected across the remaining two. These kind of networks are called as a bridged networks. Okay. So if you want to understand, you can have one more session to understand the things better. So this is how to construct a bridged T session. So generally, what is this bridge network? So you see here, if you exactly identify, so this is also a lattice network. This is an lattice network. If you mark the terminals as I shown here, this is 1, 2, 3, 4. If you mark separately, you can see here, if you redraw the network, it will be same. Okay, if you want to check also, you can check it. Let's try to draw it for this, then you will get a clarity. I'm labeling this as 1, 2, 3, 4. Now separate it, let's try to draw it. You'll get the same lattice. This is also called lattice. So now we're going to have 1, we're going to have 2, 3, node 4. So when you try to draw it, you can understand how many nodes are there between each other. So now between 1 and 2, what are there? So between 1 and 2 we have ZS. So between 1 and 2 we have ZS. 1 and 2 we have ZS. And between 1 and 4 we have ZT. So 1 and 2 we have ZS, and between 1 and 1 and 2 we have ZS, 1 and 4 we have ZD. 1 and 4 we have ZD. And next 2 and 1 is already done. 2 and 3 we have ZD. 2 and 3 we have ZD. Okay. So if this is like confusing, there's no issue also. So just you will shuffle it and you can write down. Between 2 and 3 we have is again creating and crossing. So try to remove this crossing which will create and more clarity to you. So to remove this crossing, I am reconstructing it as 1, 2, 4, 3. So between 1 and 2, so this is also correct. And this once again creating an crossing where you cannot, again you have to remove it, which creates a problem. That's what directly I'm drawing here. So this is ZS, this is also ZS. Now between 1 and 4 we have ZD. Between 2 and 3 also we have ZD. So you try to compare this with this network. So when you compare this with this network, you can see here between 1 and less names are changed. This is 1, 2, 3, 4. So here just you see here, if you relabel it as between 1 and 2, you have ZD. Okay, so this is nothing but 1 and 2 you have ZS. Between 1 and 4 we have ZS and ZD. So one is ZS, one is ZD. Just if you shuffle this 4 as 2 and this 2 as 4, this and this both are same. That's how we get from this network, we can get this network. So just change of the node, there's nothing problem here. Between 1 and 2 and 1 and 4 we should have ZS and ZD. So 1 and 2 we have ZS, 1 and 4 we have ZD. Then automatically the nodes you can change it as 1, 2, 4, 3. Just construct, you see here, this is nothing but 4 impedances. Now between 1 and 2 we have ZS, 1 and 4 we have ZD, 4 and 3 we have ZS, ZT. See here, this all are same, this is same and this is also same. That's how we can construct, we can call this lattice also as an bridge network. So therefore the conclusion is a lattice network can also be called as an bridge network. Okay, so that's how we, bridge is very very important. So the balancing of this is product of opposite. Okay, so here generally we will apply the voltage to 1 and 3. So don't need to think all the time we apply the voltage between 1 and 3. You can apply the voltage between 2 and 4 and you can connect a galvanometer between 1 and 3 also. Now I'm taking very simple, 1 and 3 I am applying voltage and I'm connecting an galvanometer between 2 and 4. So what is the bridge balancing condition? Is the product of opposite branch impedances. What are the opposite branch? ZT into ZT is equal to, what is it? So opposite, these two are opposite, ZD into ZT, and opposite of these two is ZS into ZS. Both are same. Automatically we can say that given bridge is a balanced network. The bridge is a balanced. So that's how we can understand a balanced network. Now let's try to see, in this bridge we have an balanced T section. Very very important to understand. So now the clarity is, lattice network is indirectly called as bridge network. Now let us try to see here bridge bisection. Bridge T or pi session. First we'll try to see T session and then we'll go for pi session. Okay. So here bridge T session we are going to write down. I'm taking a T session. This is an impedance. This is another impedance. This is an empty session. Here we are going to have Z1 by 2, Z1 by 2 and this is Z2. So bridged T. This is basically an T. Bridge is there. So bridge I am going to draw like this. So this is the bridge element. This I am going to call it as Z3. So now we see here is it if you take it into an half and you fold upper and lower, it is unbalanced. Therefore, I'm going to call this as an unbalanced unbalanced bridged T section. So this is a unbalanced bridged T section. So this is basically an T section but unbalanced. So what is the meaning of balance is the upper half value is not equal to the bottom half value. Therefore, this is called unbalanced bridge T session. Now, how to make it as a balanced T session? So now I want to convert this unbalanced into an balanced bridge T section. So what is this balanced bridged T section? So now this is what we call it as a series sum. So this series sum I'm going to write down it as two halves. So how to write down the series arms is it's very simple to understand. So this I can write down it as Z3 by 2 plus Z3 by 2. So the resultant we are going to get it as Z3. So this Z3 I'm going to write down it as Z1 by 2. This is also Z1 by 2, and the shunt branch we have it as Z2, and this is as it is Z2. So here this Z2 we are writing it as, the same we are writing as we are writing it as Z3 by 2 as one half, and the next half we are going to, so here the modified network it will be like this. So this half will run, and this is already Z1 by 2, Z1 by 2. This Z1 by 2 I can make into two halves, and this is a series arm. So this Z1 by 2 I can write it as Z1 by 4 plus Z1 by 4. If you take the LCM is 4, this is 2 Z1, 2 ones are 2 twos are, which is also Z1 by 2. This Z1 by 2 I can writing it as Z1 by 4 as upper part, and next Z1 by 4 in the bottom part. This Z1 by 2 I am writing it as Z1 by 4. This impedance is Z1 by 4, and this impedance is also Z1 by 4. So this is one Z1 by 4, and this another Z1 by 4, resultantly which is equal to Z1 by 2. This is Z1 by 4, this is another Z1 by 4. This is also, you can see here, these are series sums. Basically Z1 by 2, Z1 by 2 are series. So in series we have to add, so I am adding. So this is also in series, this is Z3, and I am writing this as once again Z3 by 2. Now you can see here, this when you draw an half line in between the center, when you fold, the upper diagram and bottom diagram are same. Therefore, I have been successfully transformed a unbalanced bridged network into an balanced bridge by making this Z1 by 2, which is a series branch, as Z1 by 4 plus Z1 by 4, and this series arm also I'm writing it as Z1 by 4 plus Z1 by 4, and next series arm as Z3 by 2 plus Z3 by 2. So this is what the modification I have been done here. So directly apply this modification here. So this is one Z1 by 4, this another Z1 by 4, and this is nothing but this is one Z1 by 4, another Z1 by 4, and the successfully I transform. This is already told a bridged T session, and moreover this is unbalanced. Successfully I transform a unbalanced bridge T session into an balanced bridge T session. So sometimes it's very important to understand whether the network is a balanced or unbalanced, whether it is symmetrical or whether it is unsymmetrical, whether it is a lattice network or whether it is an bridged network. So now I hope you got a clarity about what is an bridged, unbalanced and symmetrical. Now let's try to see here the recurrent networks. This is very important. So today we have been analyzed various concepts. So we analyzed what is meant by a lattice. Lattice is nothing but which has cross arms. This cross arms we call it as an lattice. This lattice in modified form we call it as bridge. And we have identified what are the things we have, and it is balanced. The product of opposite branches should be same. Therefore, the ultimate target is lattice, also called bridge network. So we constructed a black colored one which is nothing but bridged T session. This is the bridged T session, and moreover this is an unbalanced. Why it is unbalanced means the upper part is not equal to bottom part. So we transform this unbalanced system into an balanced system by doing a modification as how I explained here. So now we are very clear about the balanced and unbalanced bridged session as well as lattice session. Now let's try to discuss about the recurrent networks. Recurrent means they repeat each other. So these are called recurrent networks, or sometimes we call this as series networks, or we call them as cascade networks, or we call them as a ladder network. So when you see these networks, let us try to take a symmetrical unbalanced ladder decision. So a symmetrical unbalanced ladder T section. So T section. So here T section I'm going to construct. This is one impedance. This is another impedance. This is another impedance. This is input port. This is output port. Here I am taking the impedance as a Z1 by 2. Here the impedance as a Z1 by 2, and this has some Z2. And when you fold at the half, this Z1 by 2, Z1 by 2, therefore this is called symmetrical, and upper half is not equal to the bottom half, that's why it is called unbalanced, and this is like an lattice. So this is network 1. So now we need to construct another same network as shown below. So redraw the network and write down this as Z1 by 2, and next one is also as Z1 by 2, and next one we have another network, and we are going to join these two. So this is Z1 by 2, this is also Z1 by 2, this is Z2, and this, therefore you can see here these are connected in series, therefore this is called a series network. So cascade means the output, this is the output port of one network, this is the input port of another network, the output is connected to input, therefore we can call these kind of networks as cascade networks, or you can call them as a ladder network. So hope you understand why this network is here. So when you draw a line in half, this is Z1 by 2 and Z1 by 2, both are same, therefore I am calling this as a symmetrical network. And when you fold horizontally, so the upper part is not equal to bottom part, therefore this upper part is Z1 by 2 and Z1 by 2 is not available in the bottom part. So therefore, since it is not balanced, we call this as an unbalanced, and this resembles like an a T letter. Therefore, ultimately, what is the name of this network is symmetrical, unbalanced ladder T session. So we are joining the output to the input. That's why it is called cascade network, series network, or ladder network. This is all about recurrent networks, series networks, or cascade networks. So hope you got the basics of an all the recurrent networks, bridge network, and lattice structure. So if you feel the content is useful, please like the channel, please share with your friends, and if you have any doubts, let me know in the comment section. And this is a free channel for the benefit of the students. Please kindly subscribe to the channel with the name KV Tulsiram. Yours obediently Ram. We'll meet in the next video. Thank you for watching. So just seeing the video will not give you a sufficient knowledge. Just draw the network and convert that unbalanced into balanced, symmetrical and unsymmetrical. So then you can understand the things better. Thank you for watching.